So what is artificial intelligence? Before that, we need to know what is intelligence itself, or let us forget about artificial now. What is intelligence itself? Usually we think that intelligence is something that humans have, or some of the rare species have, but that is not the case. Intelligence is found across different animals, and I have just given here, this PPT is here, so you can refer back later. I don't want to go into the details, but you find that all these animals show intelligence, and some of them show it even better than what humans are able to do. So not in the sense that we deal with language, and that's an important topic I want to cover here. But they show intelligence, and all animals have their own intelligence for survival, which is their basic requirement. Now coming to artificial intelligence is grouped into different areas. Artificial intelligence covers the whole entire area, but machine learning, deep learning are two major areas that are covered here. And artificial intelligence got its boom in the recent years just because of new introduction of NLP related research and the outcomes of those, including ChatGPT, which is something that most of you are using. Well, I'll introduce three more other platforms which you should explore other than ChatGPT, because ChatGPT is giving only 80% accuracy, but there are other tools like Perplexity, for example. Perplexity is a tool which gives you references and can give you reliable references for everything it says, which means that if you are a research student, or if you are a student who uses ChatGPT, you should try Perplexity instead, because that is more reliable, whereas ChatGPT gives you assumptions on various aspects. The questions itself could be, they allow it to write poetry, and to write poetry kind of thing, you need imagination, and it gives a lot of imaginative ideas. Okay, what I wanted to say is about DeepSeek. DeepSeek came last week to the notice of major. It's a disruptive technology in the sense it has shown much more precise results rather than any other things. At the same time, it is about 97% less energy required. It takes only less than 4% of the total energy required by other major areas, major challenges in the field like ChatGPT, and of course there are a lot of other LLM models, large language models, which uses a lot of energy, but they are using very low energy, and it came from China. It's one of the powerful tools you should explore. One of the advantages of using this kind of DeepSeek kind of thing is that it tells you how it actually analyzes your problem. If you give it a problem, it will write down, oh, this is your question, so I'll answer it this way, and it will give you the whole logic it is going through when it does it. So that is one thing. And very recently, Google has come up with this notebook LM, which is also very useful because it allows you to upload an article. It could be a book even, a big book even, and it will read through the book and will give you summaries, and will ask, if you ask questions, it will answer those questions also. So it is very useful. So I just thought that I'll introduce these three tools to you, which would be helpful. Well, how do AI do all those things? How is AI working? Which is a question that we should ask and find out the answer. And in fact, if you go to ChatGPT, they say that it is a generative, a pre-trained transformer that they use, which is called the GPT. So this GPT is what they are using. It is a large language model. Large language model means it is based on the text language, which are books, which are text written on the internet and published by people. Okay, large language model means it refers to an area of machine learning called natural language processing, or NLP, and it is designed to generate text in the human-like languages. So that is important. If I write something like this, it's very difficult for you to understand it. But if I reorganize the words in a way, it becomes very convenient for us to understand. What I want to point out here is that all languages use rules which we call grammar. And understanding grammar is a basic thing in science, in language, or in arts. Wherever is based on rules. So understanding the rules is the major thing. And how we will understand it, how we will learn it, that is what we mean by learning. So words can be the same, but the meanings can be changed if the order is changed. For example, the cat chased the dog means entirely different from cat, dog chased the cat, or the cat and the dog chased. So all these three sentences, although the words are the same, they mean entirely different things because the order of the words changes the meaning. So the order, the grammar, all these things have to be considered, and that is what NLP is all about. So the goal is to make machines as intelligent as humans. That is what machine learning tries to do. We learn from textbooks, classes and experience. But machines learn from examples. This is the basic difference between machine learning and other streams of science. In science, usually what you start with is a postulate. You assume a model, and then you try to validate the model, you make the model better. In the case of machine learning, usually there are also model based, which are called kernel based machine learning. The other approach is to start from the data. You decide the model based on the data. So it's just a reverse process. And the process of learning is called process of course. And examples used for machines to learn are called the training data. And training data is a curated data that you provide so that the machine will be able to understand and the machine will be able to make its judgment, learn the grammar, learn the context and learn the order in which it is arranged based on that. So that is what we mean by training data, and this is a common term that comes in most of the machine learning literature. Okay, so we'll ask the question, how do machines learn from examples? And this is a kind of a network called a neural network, and this is one of the most popular models which is used across all machine learning tools, even including deep learning tools. Now it's mimicking the human brain and the neurons in the brain. In the last day, Babu sir showed this neurons image, and in fact the neuron is what helps us to learn. It has regions from where it can gather data, process the data, and of course carry the data to the other neurons. So this is a process in which the data travels, and something like that can be made on the machine, which is called an artificial neural network. So this is the structure of an artificial neural network, which is very much similar to it. And how it is similar, like the neuron nucleus, you have a hidden layer here, then like the dendrites and the axons, which are the initial, these are called dendrites and these are the axon, and from the axon ends the output comes. So likewise you have the same things here also. So you have something like synaptic weights which are in the biological neuron, which are the strengths with the chemicals are transported, because biological neuron works with chemicals, whereas this artificial neurons work with electric energy. So likewise you have synapses there and synaptic gaps there, which allows the learning to happen. And in machine learning, you have these synapses are in fact related to weights. So the strength of the connection determines the weightage given to each of the outputs is actually similar to the synapses. Now suppose we have a problem. We want to distinguish between a cat and a dog. How will we do it? What are the parameters that should go in? What are the inputs that it should go in? Well, as you can see, it could be a collection of different variables like the shape of the tail, shape of the ears, shape of the head, etc., which can go in as input, and the machine should be able to say which is a cat and which is a dog. And these inputs that go in to the network is called the features, and these outputs which are called the classes. So it's a classification problem where you try to find out what the classes are based on the input features. Now you make a prediction. That's the first thing you do. You suppose a child is shown something that he or she has never seen and asks what it is. It would guess something and say an answer which may be totally wrong. Likewise, here also when you ask the machine to make a prediction, it will make wrong predictions. It would label a cat as a dog or a dog as a cat. And that's what we evaluate. I'm sorry that some of the things are not coming up properly. But what is most important is to find out the error. Error is how much of them have gone wrong and what is the total number. The ratio is called the error, and a correction has to be applied. And what is the correction that is to be applied? Whatever be the correction that you apply, the goal is to minimize the error. Minimize the error. And how can you do that? That was what backpropagation algorithms did, and that is what made the first breakthrough in AI technology, where you find out the error, take the derivative of the error with respect to the weight, and backpropagate this error through the network, so that the network will be able to understand in what way it should change its weights, so that it will give the error minimum. So that is a backpropagation algorithm, and that was one of the major discoveries in the 80s which brought out all this revolution in AI. And the process of doing this, minimizing the error, is called training. So every network takes a training, and GPT, it was called pre-trained because they collected data up to a certain period, they trained on the machine and they gave it. So that is why it is called a pre-trained network. Okay, but there is a major challenge here. We never understand a cat by looking at its tail or its head or anything. We just look at the cat and say that this is a cat and this is a dog. But the machines, if I was mentioning, were all requiring these features to be taken out. Can we make the machine do it automatically without having to specify the shapes? And that's what deep learning does. What deep learning does is how we identify them. We identify them with the 5 sense organs, which are the 5 horses that Nambudiri sir was saying. So the 5 sense organs helps us to realize what the surrounding is and what the system should extract from it, so that it can go in as features and do this. So that is what is done, and there is something called a convolutional neural network which does this kind of thing. So the convolutional layers, in fact, it convolves the image using different kernels, which are in fact matrix multiplications, and find out which kernel. That's where it becomes kernel independent. It discovers which kernel makes the best guess about the features and gives it to the final network, which converts it into a cat or dog based on the input that is given. So this is how this whole deep learning works. Okay. Now, how can AI help in science? AI is a tool. We should remember that AI is just a tool like the calculator you use, the computer you use, or anything else. If you give garbage input, you will get garbage output. You have to, it should never be taken as a black box, and I have come across in experience through various stages in which people use it as a black box, assuming that it will do the thing, and they complain that they are not getting the answer just because it's not being used in the proper way. But if you use it correctly, this has been used by many people, and I just took this picture because Lynn Abraham is a student of myself and Moises sir, I think, when he was in BSc student, and he is now at Inter-University Center for Astronomy and Astrophysics working on the Aditya mission for developing a pipeline for the Aditya mission. So this is done entirely in AI, and that's the work he is doing, and he is doing his PhD with me now. And Aditya, I don't want to go into the details. It is sitting at the L1 Lagrange point and observing the sun 24/7, which means that even at night it can see the sun. Okay. Why is important? Because see, this is called the emissions coming from the corona mass emissions coming from the sun, and it's also called the prominence when it is very large. And what I show here is the size of Earth, and this is the kind of emission that is coming. And why it is happening, and when it happens, we have lot of disruption on the surface of Earth. More than that, to the satellites it's a great threat, because there are a lot of particles that are emitted from there, and when they hit the satellites, they damage it. So this has to be solved. And there is an observatory in space much before our Aditya observatory went there. It's called the SOHO, and SOHO has been recording it for about 10 years or more. The continuous recording of the sun is available. It's available in optical and also in magnetic field and other areas. Okay. Now, I'll just give you some examples of the various areas in which this has been used. This is the Hubble Space Telescope and the image that it took, which shows a large field. It's in fact less than a 1 millimeter in the sky size, but it's showing in the deep field, large field, mostly of galaxies alone. Almost all that you see there are galaxies, like our own Milky Way galaxy. Now we want, see, a human can sit, look at each of these images, and that was how the first quasar candidate was identified from this image. Quasar was known before that, but there were only 7 or 8 quasars that were known for studies. Quasars are, of course, quasars are star-like objects which are the center of galaxies, which are burning at a very high rate, that they appear like stars. It's like going at night and you see only the headlight of the car that is approaching you. You do not see the entire vehicle that is approaching you. So likewise, when the center of the galaxy is very bright, you see only the center, the rest of the thing remains hidden. So it looks like a star at that time, because the distinction between star and galaxies is that galaxies are extended objects, stars are point objects. Because the center is so bright, it looks like a point object, and it could be mistaken as a star. But people who do spectroscopy have found out that they have an entirely different spectra from stars, and that's how they were discovered. Well, so the question is, can we use a computer to separate these stars and galaxies? I mean, that was the first question we asked, stars and galaxies. Then the second question we asked was, can we use a machine to identify quasars from this? So how can the machines be used to count the stars, and how can the machines be used to identify stars and galaxies? So we have to make them intelligent. Okay, there is something called a citizen science. This citizen science project is something you should all go and look, because it provides a lot of data in astronomy, in healthcare, in other branches of biology, and many areas where the citizens can contribute to the science. So if you want to learn about things and if you want to contribute to science, this is a very good platform that you should explore. Okay, now let me go faster. Okay, so this is a problem that we wanted to identify, where you have an image like this. You know that this is a galaxy, but I am not sure whether these are galaxies or stars, because they are very small in size. So the question is, can we have a machine which will be able to classify this into stars and galaxies? And that question was asked, and the answer, this is an old paper, 2002. In fact, the machine learning tool that we used for this paper was developed under the guidance of BABU Joseph sir in 2000, published in 2000. And of course, BABU Joseph sir is on this paper also, which is the first and the most cited paper relating to this area in astronomy, where the other authors are also seen here. BABU sir is there. This is a recent photo I got from the internet, but at that time he was much younger than this. Okay, this is Prof. Sajeeth Ninan Philip, who was the director of IQAC, and this is Yogesh Vadrekar, who is at NCL, National, NCRA, National Center for Radio Astronomy. Okay, so this is how the paper came out in 2002, where we used this machine learning tool for the classification. And interestingly, at that time, all the astronomers laughed at us, saying that this is something ridiculous, because machines are not going to do astronomy, only humans are going to do astronomy. But in 10-20 years now, people are started changing their mind and thinking that machines should be used. Well, this is, okay, nothing can be seen there. In fact, that is a picture of a quasar. Well, now this is another just illustration showing that you see only a spot here which you think as a star, but when you mask that spot and look in detail, you find that there is a galaxy in the background which is not seen. Okay. So the question is, can machines discover quasars? The other paper was published in 2002, but this one was done by one of my students, Thelliyoor, and this work was done about 10 years later. So the question was, can we use machines to discover quasars? And this is a spectra of a star. And typically the difference between a stellar spectra and a quasar spectra is the emission lines that you see. Stars also have emission lines in special cases. Some stars do produce emission lines, but there is a way to distinguish them. So this is how quasars are usually identified in spectroscopy. But Sheila Abraham, this is Sheila Abraham, she and Rita Sinha, she was also working on this project. And of course this was done at IQAC, and Yogesh Vadnaikar also was there. They were able to develop using the same tool which I mentioned earlier, which was developed with Babu Joseph sir for doing this quasar classification. And they developed a long catalog of possible quasars. At that time about 1000, I think 10,000 quasars were known. SDSS is a dedicated survey for doing quasar survey, and in 10 years time they were able to produce about 10,000 quasar samples from doing the spectroscopic classification, and that was used for training. And their paper was able to discover several thousands of quasars from the same thing, and SDSS is continuing to discover quasars, and till date it is more than 98% accurate. So that is the precision with which machines are able to do these things. Well, then came the gravitational wave observation, and LIGO is one example for that. And when gravitational wave detectors came in, there was a postdoc at IQAC who wanted to try out machine learning tool for gravitational wave, and that also resulted in a paper. That also resulted in a paper with Nikhil and of course Sheila Abraham was there, and the other two. This is Nikhil. Nikhil was a postdoc at IQAC. This is of course faculty at IQAC, Kandusamy, and of course Sanjit is also a faculty at IQAC. So this paper came in 2017. So you see that after the first paper it took 10 years for the next paper to come. In 5 years this paper came up in the latest field. So this is also using the same DBNN technique that was developed with Babu Joseph. So that is why I thought of presenting these 3 papers, in which over the 2 decades or more than that, what was done with Babu Joseph sir is still being used. So thank you sir for being the guide. So now we come to world of generative AI, which is what this ChatGPT and all others are doing. World of generative AI includes text and also images. So I will focus on images here because that is one area in which generative AI is widely used. And what it does is that it is able to take a random generator input and create beautiful images like this. And all these images are, of course, they are not real people. They are just synthesized by the AI. Fake images. So how did they do that? They did it with by collecting the images of all the celebrities and putting it in there. There are some biases you can see there because most of the celebrities are white, and that is the reason why you find only white people there. Okay. So we did the same thing for astronomy, where we use the same generator for converting. See, in astronomy it's very expensive to go to space and make observations, although it is very precise in its analysis. But for example, Hubble Space Telescope or the recent James Webb Telescope was a plan for a long time, which took it to the space. But we have a lot of observatories on the ground, and the question we asked is, can we make ground-based observations as good as the space-based observations? And this is a great challenge because on the ground you have the atmosphere which fluctuates all the time, which is the reason why your stars look twinkling all the time, and to get back the original image from it is a really challenging task. So all right. Okay. All right. But this was done with the data we had, and this was done with another postdoc at IQAC whose name is Kaushal Sharma, and of course one person from Caltech was also involved. His name is Ashish Mahabal. So these 2 people were involved in this work. Okay. Now, one of the greatest challenges people face today is that because of this ChatGPT and all other large language models which are coming in, it has been really difficult to balance the cost and the energy demand it had. So, the energy, it is estimated that if computers continue to grow like this and the usage of computers continue to grow like this, we will burn this planet just by using computers, because it's using huge amounts of energy. And that is one of the major concerns today, and that is where the most of the electronics research is moving on, which if you are interested you should go and look. And the major point to note here is that these computers are all human made, and they, even a simple laptop like the one that is there, takes about 68 watts of power. But the brain that made all these things is using just 10 watts of power when it is working at its full power. So that is the difference between the human natural brain and the computers. So the challenge is, can we make these computers as energy efficient as the human brain? Which is a very challenging thing, because the mechanism is completely different. One is completely chemistry, the other is completely electronic and things like that. But there are certain ways in which this can be improved. One possibility is that because computers use square wave pulses, which are the clocks, you all must have learned this clock that is synchronizing all the operations in the computer. These square waves are the mathematical beauty of square wave is that it consists of infinite frequency ranges. So if you take the Fourier transform of the square wave, you get infinite series of frequencies in it. So it consists of lot of energy, and that's a major cause of energy disruption in time is over. 3 more minutes, I'll finish. Okay, so that is a major challenge here. So, well, there is something like neuromorphic computing. This is being developed by IBM and also by Intel, and there are what it does is that the major difference between the human brain and the computing devices is that, as I said, in the human brain it uses square waves, whereas in the computer it uses square waves, whereas in the human brain it is mostly working on spikes. Spikes are just their amplitude is considered, but spikes are what is used. So one of my PhD students, Arun Kumar, did a bioscience project in which he was trying to identify the event related potential, that is what it is called, event related potentials when they visualize something. And this is something that is very interesting. The human brain uses spikes, whereas computers use square waves. So these spikes, if you can use that, that's exactly what they have replicated in the in fact Intel has come up with something called this is the Intel page. They have come up with something called a Lohi 2, which is available for developers at a very reduced price, and the whole software is also open source, which you should explore, which uses neuromorphic computing, and they have demonstrated recently that it can work at milliwatt power, meaning that if your mobile phone requires charging every day, if you use this kind of technique, you will have to charge it only once. That is when you buy it. Once charged, it will last for your lifetime. So that kind of energy efficiency can be obtained with neuromorphic computing, and that is one area in which a lot of research is going on and a lot of papers are coming out also. All right, this is a paper which I would like you to go through. This appeared in 2022. That is a spike based neuromorphic computing. I'll stop here and
Thank you, sir, for your enlightening talk on artificial intelligence and machine learning. Now, the audience can ask questions. Because of time constraint, we will quickly take one or two questions. Afterwards, others can interact directly with the speaker. You will
Sir, tool intelligence it's only a tool.
Yeah. Tool can be intelligent. Intelligence എന്ന് പറയുന്നത് ഞാൻ അതിലേക്ക് പോയില്ല, but these large language models have shown what intelligence is. Intelligence is just the ability to understand grammar. If I am not able to understand a language, If I am not able to think in terms of language, my intelligence will be, I will be just like a vegetable. അതാണ് സംഭവിക്കാൻ പോകുന്നത്. അതായത് എനിക്ക് വാക്കുകളെ ക്രോഡീകരിച്ച് വാക്കുകൾ കേൾക്കുന്നതനുസരിച്ച് അതിനെ ഗ്രഹിക്കാനും പറ്റുന്നില്ല എങ്കിൽ ഞാൻ വെറും ഒരു വെജിറ്റബിൾ മാത്രമായിരിക്കും. ഐ വോണ്ട് ബി ഏബിൾ ടു ഡു എനിത്തിങ് ഇൻ്റലിജൻറ്റ്. ഇപ്പോൾ നമ്മൾ എന്തെങ്കിലും ഒരു കാര്യം ചിന്തിക്കുമ്പോൾ തന്നെ പലപ്പോഴും കുട്ടികളെ ശ്രദ്ധിച്ചാൽ അറിയാം, അവരെ ഒരു കാര്യം ചെയ്യുന്ന പറഞ്ഞാൽ പറഞ്ഞുകൊണ്ട് ചെയ്യും. അവർ അത് എന്താ ചെയ്യുന്നതെന്ന് അവർ പറഞ്ഞുകൊണ്ടായിരിക്കും അത് പലപ്പോഴും എഴുതുന്നത്. അക്ഷരങ്ങൾ നമ്മൾ പറഞ്ഞ് പഠിപ്പിച്ചുകൊണ്ട് മാത്രമല്ലത് അവരുടെ ബ്രെയിനകത്ത് നമ്മളൊരു കാര്യം പറയാൻ ഉദ്ദേശിക്കുന്നതിന് മുമ്പ് തന്നെ നമ്മുടെ ബ്രെയിനകത്ത് ഒരുപാട് തോട്ട്സ് വരും. ഇത് നമ്മളൊരു ലാംഗ്വേജ് ഫോർമാറ്റിലാക്കി നമുക്ക് ഏറ്റവും കൺവീനിയൻ്റ് ആയിട്ടുള്ള ഒരു ലാംഗ്വേജിലായിരിക്കും അതിനെ നമ്മൾ അനലൈസ് ചെയ്യുന്നത്. So this whole analysis, that is what ChatGPT and other LLM tools have demonstrated. This whole analysis says that it is in fact the ability of humans to use a language for communication, for learning, that has helped them to become intelligent as intelligent creatures on this planet. Right now it is not a proved concept, but this is something people believe, and this is something that I have been considering for some time, that it is language which has been going behind everything. നമ്മൾ ഏതൊരു കാര്യത്തെക്കുറിച്ചും അതുകൊണ്ട് ആർട്സ് ആൻഡ് ലാംഗ്വേജ് എല്ലാം തമ്മിൽ അവിടെയാണ് റിലേറ്റ് ചെയ്ത് വരുന്നത്. സാർ പറഞ്ഞപ്പോൾ ഞാൻ ഓർക്കുകയായിരുന്നു. അപ്പോൾ ഇത് വളരെയേറെ റിലേറ്റഡ് ആയിട്ട് വരുന്നതും ഇതുകൊണ്ടാണ്. ബിക്കോസ് അവർ ഹോൾ നോളജ് സിസ്റ്റം ഈസ് ബിൽട്ട് ഓൺ ലാംഗ്വേജ്. ഇഫ് യു lose it, you lose everything. And if you get it in some other form, you will get an entire different picture of the universe.
Because natural brain, because nature of chemical, it is slow. But that discrepancy is balanced by the error correction.
Yes.
Is very, very large.
Yes. Because of there are a lot of networks, and they all learn, and they, in fact,
number of hidden layers are
very large. Yesterday, in fact, BABU sir was saying about self-organization, which is actually what is happening. And in all these large language models, we use a different term instead of using self-organization, just to avoid confusion. That is to say, self-learning systems. So, self-supervised learning, supervised learning, SS something. Okay, self-supervised learning is something. Unsupervised is there and supervised learning is there. Now it is self-supervised, which means that even the computer plays with the computer. Computer try to compete with. That's how they were able to beat the world champion in chess, and also in this what was the other thing in the Chinese game that was done all this.
particular language
No, ഇപ്പോൾ എല്ലാം ഇംഗ്ലീഷ് ബേസ്ഡ് ആയിട്ടാണ് ചെയ്തിരിക്കുന്നത്. ബിക്കോസ് ദാറ്റ് ഈസ് മോസ്റ്റ് ലിറ്ററേച്ചറും അതിലാണ് അവൈലബിൾ ആയിട്ട്.
ലാംഗ്വേജ് മാറിയാൽ കപ്പാസിറ്റി റീടൈൻ ചെയ്യുമോ അതോ
ഓക്കെ സ്റ്റഡി ചെയ്യേണ്ട കാര്യമാണ്. കാരണം ഐ ഡു നോട്ട് നോ ഓഫ് എനി
ചൈനീസ് ഇപ്പോൾ അവർ
ഡീപ് സീക്ക് ഉണ്ടാക്കിയിട്ടുണ്ട്. അവിടെ ലാംഗ്വേജ് ഇംഗ്ലീഷ് തന്നെ ഉപയോഗിച്ചിട്ടുള്ളത്.
അതുപോലെ ഉണ്ടാക്കാൻ പോകുന്നു.
ഇന്ത്യ ഉണ്ടാക്കാൻ പോകുന്ന പദ്ധതി ഉണ്ടായിരുന്നു 10 മാസം ഉണ്ടാക്കും. നമ്മളെല്ലാത്തിനും പുറകെ ഓടാറുണ്ട്.
അല്ല ഈ ലാംഗ്വേജ് ഇവരുടെ ചൈനീസ് ലാംഗ്വേജിന്റെ
അതിന്റെ കപ്പാസിറ്റി വളരെ കൂടുതലാണ്. ഉണ്ട് അങ്ങനെ പറയുന്നത് പൊതുവെ. അതെ,
ഒരു പുസ്തകത്തിന്റെ
കംപ്ലീറ്റ് കണ്ടന്റ് ഉണ്ടെന്നുള്ളത്.
ലാംഗ്വേജ് മാറുമ്പോൾ
ഒത്തിരി വ്യത്യാസം വരാം. വിച്ച് ഈസ് സംതിങ് ദാറ്റ് ദി സ്റ്റുഡൻസ് ഷുഡ് ഗോ ആൻഡ് ഡു. എനർജി കൺസപ്ഷൻ മെഷർ ചെയ്യുന്നത് ഒരെണ്ണം ഹാർഡ്വെയറിന് ഓരോന്നിനും എനർജി വേണം. ഇപ്പോൾ ഇതിന് 64 വാട്ട് വേണമെന്ന് പറയുന്നത് അതിന് കറണ്ടിന് വേണ്ടി. ഏതാ? ബ്രെയിൻ്റെ പറഞ്ഞത് നമ്മൾ കഴിക്കുന്ന ഫുഡാണല്ലോ എനർജി സോഴ്സ്. ഇതിൽ നിന്ന് നമുക്ക് കിട്ടുന്ന എനർജി, നമ്മുടെ ബേൺ ചെയ്യുന്ന ഫാറ്റ് ഉണ്ട് പിന്നീടുള്ള, ഇതിൽ നിന്ന് കിട്ടുന്ന എനർജിയുടെ കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റും, എനർജി ഫുട് പ്രിൻറ്റ് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റും. എന്നിട്ട് എത്രമാത്രം ബ്രെയിൻ വർക്ക് ചെയ്തു എന്നുള്ള മെഷർ ചെയ്തിട്ടുണ്ട്. ദിസ് ഹാസ് ബീൻ ഡൺ ഫോർ എ ലോങ് ടൈം. അപ്പോൾ ഒരു അക്രോസ് സിവിലൈസേഷനിൽ ഈ ബ്രെയിനിന് 10 വാട്ട് പവർ മതി എന്നുള്ളത് അവർ ഐഡൻറ്റിഫൈ ചെയ്തു. ബ്രെയിൻ ആകെ എനർജിയുടെ നമ്മളെ എടുക്കുന്ന എനർജിയുടെ ഒരു പെർസെൻറ്റേജേ പോകുന്നുള്ളൂ. പക്ഷേ ദേ ഹാവ് മെഷേർഡ് ഇറ്റ്. എനിക്ക് അതിൻ്റെ ഡീറ്റെയിൽസ് അറിയത്തില്ല, പക്ഷേ ദേ നോ ദാറ്റ് ഇറ്റ് ഇസ് 10 വാട്ട്. യൂട്ടിലൈസ് ചെയ്യുന്നില്ല. ഫുൾ ടൈം എക്സാമിനേഷൻ എഴുതുമ്പോഴോ ഒരു ടോക്ക് കൊടുക്കുമ്പോഴോ മാത്രമേ ഉപയോഗിക്കുന്നുള്ളൂ. ടൈം ഈസ് അപ്പ്. കേട്ടില്ല ഇല്ല. ഈ അതായത് വെബിലുള്ള എല്ലാ ഇൻഫർമേഷനും നമുക്ക് യൂസ് ചെയ്യാനായിട്ട് മീഡിയ അവൈലബിൾ ആയിട്ടുള്ളതാണ് ഉപയോഗിച്ചിട്ടുള്ളത്. അതുകൊണ്ട് തന്നെയുള്ള റിസ്ട്രിക്ഷൻ ഉണ്ട്. അതുകൊണ്ടാണ് ബയാസ് വരുന്നത്. പലപ്പോഴും ഈ കളർ ബയാസുകൾ അല്ലെ ഈ മറ്റ് ബയാസുകളൊക്കെ ഈ LLM-നകത്ത് പലയിടത്തും ഉണ്ട്. അത് അവർ പലതും അറിയുന്നതനുസരിച്ച് അവർ ബ്ലോക്ക് ചെയ്യുന്നുണ്ട്. കാരണം മോസ്റ്റ്ലി ഞാൻ മുമ്പേ പറഞ്ഞല്ലോ, അഡ്വർടൈസ്മെൻറ്റിനകത്ത് മോസ്റ്റ്ലി വൈറ്റ്സിൻ്റെ പടം വരുന്നതിൻ്റെ കാര്യം സെലിബ്രിറ്റീസൊക്കെ വൈറ്റ്സ് ആയതുകൊണ്ട് പോസിബിളി അങ്ങനെ വരും. അതെ അതെ, അത് ഉണ്ടാക്കുന്നത് അവർ തന്നെയാണ്. ഇല്ലില്ല, അതുകൊണ്ടാണ് ഇത് ഷുഡ് ബി യൂസ്ഡ് ആസ് എ ടൂൾ എന്ന് പറയുന്നത്. നമ്മളതിനെ അനലൈസ് ചെയ്യണം. ഏത് ഔട്ട്പുട്ട് കിട്ടിയാലും അനലൈസ് ചെയ്യണം. അനലൈസ് ചെയ്തിട്ട് കറക്ഷൻ ചെയ്യാൻ പറ്റും. വൺ ഓഫ് ദ അഡ്വാൻറ്റേജസ് ഈസ് ദാറ്റ് മോസ്റ്റ് ഓഫ് ദീസ് ലാർജ് ലാംഗ്വേജ് മോഡൽസ് ആർ ഏബിൾ ടു റൈറ്റ് കോഡ്. പ്രോഗ്രാം എഴുതാൻ പറഞ്ഞു കഴിഞ്ഞാൽ എഴുതും. വേണം. എങ്ങനെയാണ്? ആ അല്ല, ഡീപ് സീക്ക് അവരുണ്ടാക്കാൻ കാര്യം അവരെ സാങ്ഷൻ ചെയ്തിരുന്നു, US സാങ്ഷൻ ചെയ്തിരുന്നു. എന്നിട്ട് അവർക്ക് മെഷീനറി കൊടുത്തില്ല ചൈനയ്ക്ക്. സോ ദേ ഡെവലപ്പ് ദെയർ ഓൺ സിസ്റ്റം. അപ്പോൾ അവർക്കുണ്ടായിരുന്ന മെഷീനറി എന്ന് പറയുന്നത് ഇത്ര എനർജി എഫിഷ്യൻ്റ് അല്ലായിരുന്നു, എനർജി ഉള്ളതല്ലായിരുന്നു. സോ അതിൽ അവർ ഇൻവെസ്റ്റ് ചെയ്തിട്ടാണ് ഈ ചെറിയ സിസ്റ്റത്തിനകത്ത് മോസ്റ്റ്ലി സോഫ്റ്റ്വെയറിൻ്റെ അഡ്വാൻറ്റേജ് ആണ് ഇത്. അതിൽ